Hey y'all, welcome back to another video. Today's first question is, a church rings its bells every 15 minutes, the school rings its bells every 20, and the daycare center rings its bells every 25 minutes. If they all ring their bells at noon on the same day, at what time will they all ring their bells together? So this problem sounds a little bit complicated, but in reality, you just need to find the least common multiple. And then since it's going to be in minutes, you're going to have to convert it to hours and then add it over the noon, basically. So to find the least common multiple, you have to prime factorize all the numbers. So you know that 15 is 3 and 5. 20 is 2 to the power of 2, which is 4. And 5, and then 5 to the power of 2 is equal to 25. So now to find the least common multiple, you need to pick out the largest number from all of your selections and then use that and multiply it with everything else. So we got 2 to the power of 2, because that's the only 2 you have, multiplied by 3, multiplied by 5 to the power of 2, because 5 to the power of 2 is the greatest one you have. So 5 to the power of 2 is 25, times 2 to the power of 2, which is 4, so that's 100, so 300. But as I said, this is in minutes, so you have to convert it to hours, in which you would divide by 60. So then that would be 5. So plus 5 hours, it would be at 5 p.m. exactly. Moving on to problem number 2. This problem is actually quite similar, just like out of context. The number 16128 is a multiple of 6, 7, and 8. What is the smallest multiple of 6, 7, and 8 that is greater than 16128? So this problem is very similar to the one above, except imagine 16128 as noon, and then 6, 7, and 8 as the times when the bells chime, basically. So we're still prime factorizing everything, except 7 is already a prime factor, and every 6 and 8 you just need to do one time. So basically, 6 and 8 you can write as 6, you can write as 2 and 3, 2 times 3. And then 7 is just 7. And then 8 would be 2 to the power of 3. 7 is just 7. 7 is 1 and 7, but 1 doesn't count. So you would go pick out the largest 2, so 2 to the power of 3, times 7's lonely 7. Not lonely anymore. So then you would go 21 times 8, which is 168. So now you just add 168 onto 16128 to get your final number, because this is basically adding it onto the noon in the previous context. So, except you don't have to convert it this time, which is nice. This would be 9,261. So the answer to this problem is 16296. So yeah, that's the end of this video. I hope you guys learned something new, and I hope you guys enjoyed, and I'll see you guys on the next one. Bye!